The supermassive black hole at the heart of our Milky Way Galaxy is a quiet monster. However, Sagittarius A, or Sgr A for short, is not totally dormant. Occasionally, it gobbles down a blob of molecular gas, or even a star, and then suffers a bit of indigestion that emits X-ray flares to surrounding space. Sgr A is the closest supermassive black hole to Earth, at a distance of 26,000 light-years. Studying the nearby environment is tough due to the black hole's intense gravitational pull. It distorts the view of nearby objects, making them difficult to observe. However, there are ways to do it by looking at the effect of its flares on nearby molecular clouds. Astronomers recently found the centuries-old echoes of previously unknown flares that occurred long before there were telescopes to observe them. Those echoes indicate that Sgr A eats fairly often. Two researchers from Michigan State University, Sanger-Johnson and Jack Uteg, studied the flares and their light echoes in detail. What they found shows activity at Sgr A in the very distant past when Sgr A ingested material. X-ray emissions from that activity traveled for hundreds of years from Sgr A to bounce off of and brighten a nearby molecular cloud. That created a light echo that traveled another roughly 26,000 years before reaching Earth. So when Uteg and Sanger studied these flares and light echoes, they were literally looking into the past. Sanger-Johnson analyzed 10 years worth of data looking for X-ray flares generated by Sgr A's eating habits. During the search, she found evidence for 9 more such outbursts. The flares are typically quite dramatic because they're so bright. They provide astronomers a chance to study the immediate environment around the black hole. The data Sanger-Johnson studied came from the NuSTAR mission. It zeroes in on high-energy X-ray and gamma-ray emissions. These typically come from active regions in the hearts of galaxies, supernova explosions, and other active events. The data Sanger-Johnson collected and analyzed is now a database of flares from Sgr A. We hope that by building up this bank of data on Sgr A flares, we and other astronomers can analyze the properties of these X-ray flares and infer the physical conditions inside the extreme environment of the supermassive black hole, Sanger-Johnson said. While Sanger-Johnson was working with the NuSTAR data, undergraduate researcher Jack Uteg studied the activity around the black hole. He analyzed 20 years of data about a giant molecular cloud called the Bridge. The data came from observations made by NuSTAR and the European Space Agency's XMM Newton Observatory. The Bridge lies close to Sgr A and normally wouldn't give off its own light. So, astronomers took notice when it brightened up in X-rays, according to Uteg, who is constructing a timeline of Sgr A's past outbursts. The brightness we see is most likely the delayed reflection of past X-ray outbursts from Sgr A, he said. We first observed an increase in luminosity around 2008. Then, for the next 12 years, X-ray signals from the Bridge continued to increase until it hit peak brightness in 2020. Uteg's work helped astronomers determine that Sgr A was about 5 orders of magnitude brighter in X-rays than it is now. That brightening indicates our central supermassive black hole had probably cannibalized a nearby gas cloud, and the brightness revealed other properties, according to Uteg. One of the main reasons we care about this cloud getting brighter is that it lets us constrain how bright the Sgr A outburst was in the past. He said, "What those light echoes from Sgr A reveal, thanks to Sanger Brown and Uteg's work, astronomers have another way around the difficulties of observing around black holes. Both flares and fireworks light up the darkness and help us observe things we wouldn't normally be able to," she said. That's why astronomers need to know when and where these flares occur, so they can study the black hole's environment using that light. Astronomers know that the black hole does gobble up nearby material on a variable basis, but these findings help them constrain how often it happens and how the resulting flares affect the nearby neighborhood. Many questions remain about how often these flares occur and have happened in the past, according to MSU assistant professor Shuo Zhang, who acted as team lead for these 2 studies. This is the first time that we have constructed a 24-year-long variability for a molecular cloud surrounding our supermassive black hole that has reached its peak X-ray luminosity, Zhang said. It allows us to tell the past activity of Sgr A from about 200 years ago. Our research team at MSU will continue this astroarchaeology game to further unravel the mysteries of the Milky Way's center. And there you have it, an incredible glimpse into the mysterious heart of our Milky Way Galaxy. Thanks to the dedicated dedicated efforts of researchers like Sanger-Johnson and Jack Uteg, we're uncovering the secrets of Sagittarius A and learning more about the powerful forces at play in our universe. As we continue to study these cosmic phenomena, who knows what other fascinating discoveries await us? If you enjoyed this video, don't forget to like, share, and subscribe for more exciting updates on space exploration and astronomy. Leave a comment below with your thoughts on this discovery and let us know what other space topics you'd like to see covered. Thanks for watching, and until next time, keep looking up at the stars and wondering what lies beyond.